Welcome back to the Puddin' Creek Rod Shop. Now, when Doug finished the Purple Beast, that brand new 327 engine, I brought it home and I set it right here by the door. So every morning when I come into work and I unlock the door, I almost trip over it to get in. Now that's for motivation. When I come through the door with my coffee cup in hand and I almost trip over that awesome purple engine, that reminds me, get to work on the Bad Coupe. Now, as you can see from all the C-clamps and pry bars and hammers and punches and vice grips and assorted implements of destruction, we have waded knee-deep into this X-Member project. Now, if you guys remember from the last episode, we did the driver's side leg. We cut it and heated it and bent it and got it just the shape we wanted and fitted it to the frame. And our first job this morning is to match the passenger side leg up to the driver's side leg. Let's get at it. Now that's the driver's side finished leg on top, and I've got it clamped up to the passenger side, which is on the bottom. And I've already cut all the notches in the passenger side. So all we've got to do this morning is real quick, heat it up and put all these bends in it. I'm not showing it on camera, but as I heat these up and bend them around to their final position, I put some welding clamps on the back side to hold them in that position. When you heat metal up and you move it this much, as it cools off, it wants to draw and move positions, and you'll end up with a different shape than you actually want. Same thing with welding metal. Anytime you start welding on one side of two pieces of metal, the metal's going to draw or bend or move around, and you've got to have things clamped up to where that doesn't change the shape of what you're trying to build. Another thing you always have to think about when you're welding metal or moving metal or machining metal is that pieces like this have stresses built up in them. When they put these in the dies and they bend them around into this shape at the factory, that puts stresses in the metal. Also, when the metal was made at the steel mill, when it was originally rolled through the rollers to squeeze it down to 1/8 inch thickness sheets, that put stresses in it. So when you cut metal, those stresses relieve and the metal moves around. So you've always got to be aware that there's a little bit of science in this. That's right, I said it, science! All right, now we have a matching pair of X-Member legs. I feel like we're making real progress now. Now, you guys have seen me use this old antique Stanley number 1299 utility knife many times before, and I know what you're thinking. Oh, Puddin' Creek, that's cute. You're using antique tools to make your videos more interesting. Well, that is a tiny little bit of it, but the main reason I use this knife is because of the way it fits in your hand. It's short and stubby, and it's real thick here on the handle, and it just lays perfectly in the palm of your hand, especially when you need to cut a radius or a circle. I mean, you can twist it and move it. Now, by comparison, a modern-day utility knife is so long and bulky, which is it's designed to be ergonomic, but you can't really move it with your hand. You have to move your whole wrist and your arm, and it just makes it kind of awkward to do any kind of precision work. But by contrast with the old Stanley 1299, you can hold that right in the palm of your hand, and you can move it with your fingers to cut around curves and cut radiuses. I mean, it makes it super precise. You know, it's kind of the same theory that old school pinstripers use. Old school pinstripe guys, they use these sword-shaped brushes, and the thickness of the bristles varies from one end to the next. Now, to pull a straight line, they just lay it down flat and pull it toward them. But to do a curve, to pull a radius or make a circle or a half circle, they actually twist the brush between their fingertips, and that maintains the same line thickness. If you just pulled it around, it would make a different thickness of a line. So they actually rotate it or twist it, and that's the reason the handle's nice and short and stubby, is so it kind of lays inside your hand as you roll it between your fingertips. Same principle with my Stanley 1299 utility knife.
A little place called Hamburger Dan's. Well, the waitress there, she poured me my coffee, and I thought I heard a song about a truck driving man. Oh, pour me another cup of coffee, for it is the best in the land. Or I'll put a quarter in the jukebox and play me a truck driving man.
Now, one of our viewers left a comment on one of the Bad Coupe videos and said he remembered seeing the car back at the Columbus Street Rod Nationals back in the day, and he thought it was such a cool car that he got his wife or his girlfriend, and his buddy got his wife or girlfriend to stand in front of it, and he took a picture with the girl standing in front of the Bad Coupe. And I told him I sure would like to have a copy of that picture and sent him my email address. So far, I don't have it, but if he ends up sending it, I'll be sure and share it with you guys. But on the other hand, the original builder and owner and designer of the Bad Coupe, John Lackner, he sent me an email, and one of his sons had dug around and found 2 more pictures of the Bad Coupe. Now, I don't know about you guys, but I get really excited every time a new picture of the Bad Coupe surfaces. Just seeing the car with its original blue grille shell and the paint not faded out or cracked and the interior not faded and looking bright and new, I mean, it really gets my old heart pumping. This picture right here that they sent me, this is one of my favorite ones of the car ever. Those 2 young boys piled into that high-back Corvette bucket seat, both of them sharing one bucket seat. Man, I bet that was fun. Now, the little woman and I, we're still researching places to buy that Yeti fur carpet. Remember that real thick white fur carpet that was in the car from the 1970s? We haven't actually found any carpet that's white fur so far, but we found some rugs that might work. They look pretty much like the same thing, and they're pretty good-sized rugs. You know, if only there was some way you could hunt one of them Yetis down and skin him for his hide. But I don't know where in the world in East Tennessee you'd ever find a big giant Yeti to skin. Ah, she gonna get me good when she sees this one, boys. I may have to come over and eat supper with one of you guys tonight. Now remember, general rule of thumb, if you're welding with a MIG welder, you want to leave a gap. If you're welding with a TIG welder, you want no gap. Now, if your day job is working as a welder for SpaceX and you're qualified to weld Hastelloy and Inconel and titanium, and you're saying, hey, Puddin' Creek, there's a lot more to this welding thing than just gap and no gap. Well, I agree with you, but my tips are all geared toward people just starting out or beginners in the hobby. Just a little tip to help get you going, to kind of push you off in the right direction. I don't have any business giving tips to people that actually know what they're doing. Now, I know what you're thinking about right now. Hey, Puddin' Creek, why don't you unbolt that big steel bar going across there, and then that piece of aluminum would be a lot easier to get out. Well, I think that big piece of steel bar is what's holding the whole body in position. I think that's what they used to set the height of the body on the frame when they channeled it down over the frame. I think that's pretty much the most structural piece in the whole car. So we're not going to unbolt it. Well, I've got the two legs of the X-member installed into the frame now. They're all drilled and bolted and fitted. Everything's looking great. Now, the next step is I need to make a piece to connect them together at the top. This is just a piece of aluminum that's 1/8 inch thick, which is what I'm thinking I'm going to use, because that's the thickness of the top of the frame rail. So that's the gap I have between the top of these X-member legs and the floor is 1/8 of an inch. Anyway, I'm just test fitting that to make sure my idea is going to work. And then before we can get too serious about it, we're going to have to make a run to the steel distributor and pick up some plate metal to actually make these pieces out of.
She makes good cornbread. She makes good cornbread. She makes good cornbread. It's the best in town. I got a little woman about 5 feet tall. She sings like an angel, boys, and that ain't all. Whatever she says is the law of the land. She keeps a cast iron skillet in her right hand. She makes good cornbread. She makes good cornbread. Makes good cornbread. It's the best in town. Well, I like fried okra and I like sweet tea. I like the way the little woman loves on me. She loves me in the morning and she loves me at night, but she really gets me going about supper time. She makes good cornbread. She makes good cornbread. She makes good cornbread. It's the best in town. Surprise, she wasn't making no cake, she wasn't making no pies. My eyes bugged out and my mouth was gaping. Didn't have nothing on but her old cooking apron. She makes good cornbread. She makes good cornbread. She makes good cornbread. It's the best in town. She makes good cornbread. She makes good cornbread. She makes good cornbread. It's the best in town. She makes good cornbread. It's the best in town.
Well, we made it to Morristown, Tennessee. We're here at East Tennessee Steel Supply. Good googly moogly. Look at that bandsaw. If General Chow's bandsaw saw that bandsaw, he'd be green with envy. No firearms allowed. Boy, times sure have changed. I remember back when I used to work in the machine shops, just about every machinist had a pistol or two stuck in one of his toolbox drawers. I mean, at lunchtime and break time, we'd work on them and modify them and machine on them, and we'd buy them and sell them and trade them. And the machine shop owners knew we had them. They didn't care. He had pistols in his office, too. Boy, things sure have changed. This building looks like Earnhardt got into its rear quarter panel going into turn 3. Rubbin's racing, you know. Well, what I needed was some 1/8-inch thick steel for the top piece that ties the two cross-member legs together, and some 3/16 thick steel for the bottom piece to tie them together. Now, when I called down there, I just wanted to get like a 2-foot by 3-foot piece of each, but the guy said that that's a $200 laser charge to cut it, and they still charge you for the full 4x8 sheet anyway. So you're way better off just to go ahead and buy a full 4x8 sheet of each. So that's what I got. So we've got plenty of steel plate. We're going to have plenty left over for future hot rod projects. You know what the old saying is, never trust a carpenter that has a brand new tape measure. Now normally I would take a framing square and check the factory edges for square and see if I needed to cut the sides to square them up too, but for this it doesn't really matter. We're just going to rough cut a piece off, and then we're going to slide it up on top of those cross member legs, and eventually when it's all back out and into the floor, we're going to cut it probably to the shape of the cross members, probably be cutting some curves into it. So it doesn't really matter if it's square or if it's perfectly straight at this point in the game. Now all of these holes that I've been drilling in the legs of the new X member, I've marked them a 1/2 inch in from the outer flange. And the reason I picked that dimension is because that's exactly where that 90-degree Bosch drill would drill. If you go any deeper in toward the inside, the head won't clear, it bumps. So if I drill all these holes a ½ inch in from the edge, then I can use my 90-degree Bosch drill to do it. All right, we've got the lines laid out exactly a ½ inch in from the outer edge. I've got the new piece of 1/8 inch thick steel sheet already slid in above the X-member legs. And the game plan here is I'm going to drill some real small pilot holes, and then I'm going to use self-tapping screws. I know, don't get excited. These are just for temporary, and I know self-tapping screws don't require a pilot hole, but this is going through the 1/8 inch thick legs for the cross member, and also the 1/8 inch thick sheet metal that I've got on top of it. So by my county education, that's a 1/4 of an inch that it's going to have to go through. So I drilled a little pilot hole first, and then I'm going to run these self-tapping screws through there. Now the self-tapping screws are just to give me locations. Once I have this assembly all kind of put together with self-tapping screws, I'll unbolt the whole deal from the frame and lay it out in the shop floor, and I'll drill and put 3/8 bolts everywhere there's a self-tapping screw. But the self-tapping screws just let me line everything up and get it into position like it's going to be when it's finally done in the car. All right, I put 2 more self-tapping screws up front. That's a total of 4. That'll hold that 1/8 inch thick steel plate in place. And the next step is to go up on the top side. I need to mark the hole location for the Hurst shifter handle to come up through the floor. It's got to come right up through the top plate on this cross member or X member. Now, I may end up remaking this plate right here, or I may just dress it up a little bit and put it right back in like it was before in the end. You guys know that I'm trying to keep this car the way it was originally built as much as possible. Just because a part looks crude or a weld looks rough, I'm not replacing that kind of stuff. I'm only replacing things that might make the car dangerous. Other than that, I'm pretty much trying to keep it just like it was built. It doesn't matter if it was cut with a cutting torch or gnawed out with a set of nippers. However it was built, it's how it's going back together, unless it's dangerous. Now that's as much as I can do on the top plate until we get the whole deal out of the car and on the shop floor. So now let's start thinking about the bottom plate. The bottom plate's going to be 3/16 of an inch thick. It's going to be a heavier steel plate. It's going to be bolted on. It'll be removable at all times. Before I make a pattern for the bottom plate, I'm going to go ahead and slip the drive shaft into position because I'm going to need a notch at the back of this plate to clear the drive shaft as the rear end moves up and down. I don't have any of that bookboard material to make this big of a pattern out of, so we're back to a piece of cardboard, or pasteboard as my old machinist buddy used to call it. And this particular piece of pasteboard looks like it was the one I was testing my spray pattern on when I was painting the purple paint on the valve covers. Anyway, the first thing I'm going to do is square it up, make it a nice square piece, and then we'll hold it up there and try to get some idea how we want to make this bottom plate. The hardest part of this is trying to center up a perfectly square plate on an X-shaped cross member. I mean, it's hard to get that centered. So the first thing I did is I put 2 stops up at the front of the transmission cross member there, and that way I can slide it up against those stops every time I take it in and out. Right now I'm measuring side to side from the original 32 Ford, Henry Ford frame rails and trying to center it up that way. It's not the easiest thing in the world to do, though. right, like the sticker says, break's over. Let's get it. Now, the first thing we're going to do this morning is check the edge on that 3/16 thick plate and see if it's straight enough to make one of the edges for the crossmember plate that we're about to fabricate. Now, a cardboard pattern is not going to give you perfectly straight or square lines. It'll give you a guide. That's about it. So what we're going to do is we're going to take that front edge that I checked with a straight edge, which was pretty well straight, and we're going to make all of our lines, we're going to square them off that front edge. That way the whole plate will be squared off of one locating surface. Right here is a tool that you guys have never seen me use on our channel, and there's a good reason for that. You see, we've only had a YouTube channel for about a year and a half, maybe not even that long, and I bought this plasma cutter 5 or 6 years ago and only used it one time. I know that's hard to believe, but that's the honest truth. I only used this thing one time and never used it again. Right under the same piece of plastic is my TIG welder. I use it all the time. But I've only used a plasma cutter one time. You guys follow me right back here and I'll show you what I used it on. That's what I was using it on right here, my 1933 Chevy Coupe project. If you remember, this car in the 80s, some guy had done some work on the frame, not very good work. It had a lot of angle iron brackets and junk on it. Anyway, about 5 or 6 years ago, I pulled the frame out from under it, sent the frame off and had it sandblasted. And I was cutting all those homemade brackets out from under it when I ran out of acetylene. So I thought, well, why not use this new plasma cutter I just got? I just pulled it out of the box. So I fired it up and was just basically using it like a cutting torch. I was just whacking off angle iron and old welds, and it worked great, but I wasn't trying to do any precision work with it. I was just trying to get this frame back down to the way it was in 1933 when Chevrolet made it. So I know the question you guys are asking, Puddin' Creek, why in the world have you not used this plasma cutter in 5 or 6 years? Well, it goes kind of deep. You see, I'm a product of 80s and 90s machine shop culture, and in the 80s and 90s, I don't remember any machine shops having a plasma cutter. The way we made pretty much everything out of plate metal is we laid it out, usually sprayed it with blue dicum and then scribed the lines out. And then we'd move it to a big do-all vertical bandsaw and saw it to shape roughly, leave it a 1/16 of an inch oversize, and then we'd move it to the Bridgeport Mill and start milling it in square. I don't remember any of the little machine shops I worked at having a plasma cutter. I actually don't remember even seeing plasma cutters till around the early 2000s. So I'm looking at this little 3-foot long 220-volt pigtail, and I'm wondering how in the world am I going to plug this into my 220 outlet that's about 20 feet deep inside the shop. And then I remember, oh yeah, the Tom Hanna auction. Right over here in B Complex, that's where the 37 Chevy Coupe is stored, and some front end springs and assorted car parts. And there's my brother's X-frame out of his 1964 Impala. He was in the process of wrapping that frame and got sidetracked. Anyway, right here is what we're looking for. You see, I bought this at Tom Hanna's estate auction. Tom had made up this cool 220 drop cord mounted onto a hand truck. You can see it still has the auction number right there on it. And he put a female outlet. He mounted it right to the hand truck, which is just super handy. You just can roll it up outside or wherever you're going to use it. And it's got a male plug here on the other end. Now, being as this is the second time I've ever used this plasma cutter, and the first time that I've ever tried to actually follow a line with it and cut something straight, I decided I better take a test pass with it, maybe a couple of them, and just get a feel for it before I start messing up our project. All right, practice time is over. We got to get the Bad Coupe on the road. Ain't nobody got time for any more practice. Let's start cutting this plate out. Well, I cut about 2 inches, and then I stopped to see what I've got. It's actually cutting great, but when I stop and look at it, I'm leaving a lot of material to be ground off. If I leave that much material, I'll be out here to midnight grinding. I'm going to have to move on over and get close to the actual finish line. Don't be scared of it. You know what they say, if you're scared, say you're scared. I ain't scared. Well, not too bad. I mean, for the first time ever. I did get a little shaky right there toward the end, though. Note to self, don't drink 3 cups of coffee on the day that you're going to use a plasma cutter. Now, I know you guys are getting carpal tunnel from typing in the comments right now. Puddin' Creek, you don't know how to use a plasma cutter. You have no idea what you're doing. Well, that's what I told you before we started this project. I think that's almost exactly what I said. I have no idea what I'm doing. I've never used this thing before, except to whack off some angle iron brackets. Now, I won't torture you guys with any more footage of me trying to cut with this plasma cutter. I realize if you're good with a plasma cutter, this is probably like watching a baby duck learning how to walk. I only had a couple of bad spots. I got into my line right there. That's going to have to be fixed. I can just touch that up with a welder, no big deal if I need to. And then right over here, I think the caffeine got me and my hand kind of jumped for no apparent reason whatsoever. Again, it's easy to fix metal if you own a welder and a grinder. All in all, with this being the very first part that I've ever cut out with a plasma cutter in my whole life, I think it's pretty decent. Now, I'm not doing a review on this thing. I mean, it's 5 or 6 years old. I don't even know if they still make this model anymore. But I will say it works great. So there's that. Let's see if we can see what model it even is. Looks like it's a Versa Cut 40. Again, I have no idea if they even make these anymore, but this one works great. Now remember, I clamped up these 2 locating stops before we started this project. That way, every time I took out the pattern in and out, it would locate it at the exact same position. Same thing for the metal part now that I've actually got the plate made. Every time I take it in and out, it'll locate back to the same position for me. Now sometimes I'll use this method just to rough in a big plate. I just put a hardened 3/8 diameter dowel pin in a drill chuck, and I'm just running the x-axis of the mill table back and forth, and I'm kind of letting that dowel pin just kind of bump the plate over straight, or I'm bumping it with my hand. That gets you real close. That'll get you within, 20 or 30 thousandths, or maybe even less, and plenty close enough to switch to a dial indicator. Now, for indicating in a big, giant, rough plate like this, you don't want an indicator that's real finicky. You don't want a last word indicator or a best test brown and sharp indicator. You want an indicator like this that's got a lot of travel, and it's got a big, fat indicator probe button there on the end so that it doesn't get caught in the roughness of the plate. You need that big radius so it glides along the edge of the plate. Now we need to mill out this pocket. Now guys break in mills all the time trying to mill pockets on Bridgeport mills. What happens is when you get to the back edge of the pocket, the cutter digs into the material, the corner there, and it breaks the end mill off. Well, I'm going to show you how to prevent that. First of all, lock down the axis you're not using. That's the x-axis right now. And you can snug or put a little drag on the axis you are using. That's the y-axis. That's what I have my left hand on, is the y-axis clamp. Now, as I get on back toward that corner, when I get into that corner, I'll go ahead and lock that axis down, and then I'll reach over and I'll turn the slop out of the lead screws before I unlock the x-axis. That way it can't jerk the slop out of the Acme lead screws and dig into the corner and break the end mill. You see, Bridgeport manual milling machines came from the factory with Acme lead screws. That's an Acme thread on the lead screw and an Acme thread inside the bronze nuts. Now there's clearance or slop or slack in between the threads on the lead screw and the nut, just like there is a bolt in a nut. It's not perfectly tight. So therefore, when your end mill gets into a corner, it wants to jerk that clearance or that slop out of the lead screw, and that's what makes it dig into the metal and break your end mill. So when you're milling pockets on a Bridgeport milling machine, your whole thought train should be about how do you minimize it jerking the slop out of the lead screw and the bronze nut. That's what'll change your milling around and make you successful. All right, now we've got all the milling cleaned up. We've got the edges cleaned up nice and clean. Now we need some bolt holes to be able to bolt this plate up to the bottom of the X-member legs. Normally, if I'm going to drill holes on the Bridgeport milling machine, I would use an edge finder to pick up 2 edges and then use the digital readout to dial off my hole locations. But since this part has these 2 free-form shapes on the sides here, I'm not able to do that. So what we'll do is we'll just lay them out with a scale and a silver pencil. These are just bolt holes. There's nothing super precise about them whatsoever. Now notice I still haven't welded up these cuts that I made in the X-member legs. I'm leaving them until we get this bottom plate drilled and mounted and bolted and everything tightened down tight, and the top plate also. That's actually one of the very last things I'll do will be to weld up these splits. I want these to be open so that these plates, as they bolt together and they pull everything parallel and square, that has some a place to give there, some relief. I need to move the flange on the right side up just a little bit, maybe a 1/16 of an inch, to make it even with the flange on the left side before I tack weld it. To do that, I'm using a screw jack. Now, I didn't record it, but I went through and I tack welded all those splits, all those cuts I put in the X-member legs that allowed me to heat them and bend them around to the shape I needed. Now they're all tack welded in place, and now we can pull this whole assembly out and get it on the shop floor and continue on. Now I'm going to put a clamp on here to hold it in position, and then I'm going to remove these self-tapping screws one at a time, and I'm going to use the hole that's pre-drilled there from the self-tapping screw. I'm going to enlarge that to a 3/8 hole so I can put a 3/8 bolt in that hole. Now you see how this plan was working. I used the self-tapping screws when I had it up in the car to get my locations, get everything set and square and parallel. And now I already have my locations. I have my holes pre-drilled. I just pop that self-tapping screw out, open it up to a 3/8 and put a good 3/8 bolt in there. All right, now I have all the holes drilled and both plates bolted up with 3/8 bolts. Everything's tight, everything's square and parallel, just like it will be when it's finally installed in the Bad Coupe. So now the next step is to take my silver pencil and to mark off this excess material that I need to cut off to make it fit the shape of the X-member legs. All right, now that I've got my cut lines marked, I can go ahead and pull these 4 bolts out, take this plate off, take it outside, fire up the plasma cutter. There sure is a lot of work in building an X-member. What do you guys think? They say it takes 10,000 hours to master any skill. I've got about an hour of experience on this plasma cutter, so I got a few thousand hours to go. Now, in my limited experience so far with this plasma cutter, I've already learned you don't want to drag the tip on the metal. So with this time, I'm trying to hold it up off the metal a little bit. And I've learned that the biggest problem is seeing the line. the plasma tip is so big when you're standing up over top of it, it kind of hides the line. You can't see what you're cutting. So it worked better for me to get down on eye level with it so I could see the line. I mean, I tried it up, down, every which way, but that's my biggest problem with it. I don't really have much problem with the control of it or the heat or any of that. The only problem I seem to be having is I can't see the line I'm trying to cut. Now, on the other piece, when I used a guide or a fence, I had it clamped to it there, and I could pull it along that guide. That worked great because I didn't need to actually see the line. But to cut these curves, these free forms, I need to actually see the line I'm cutting. Well, I wouldn't say I've got any better than I did the last time, but I haven't got any worse, so there's that. Man, oh man, this cross member sure has turned into being a lot of work. I feel like I've been ironing all day with a baby on my hip. Well, we still got to finish weld all these notches. And we've got to cut the hole for the hearse shifter to come through. And we got to finish weld all these bend joints that are tack welded together right now. And we've got to clean the whole thing up, strip it down to bare metal and prime it and paint it black. But we're getting pretty doggone close to having a finished cross member for the Bad Coupe. Well, friends and neighbors, that's our show for this week. If you enjoyed the show, leave us a comment. That helps us out with the bigwigs up at the main YouTube office. And if you want to buy some Puddin' Creek junk, I mean Puddin' Creek merch, just go over to puddinCreek.com. And as always, don't forget to subscribe if you haven't already.